Okay, so we're going to review some multiplication and division. So remember that when we're multiplying that we just factor, and if you have a single factor on top and a single factor on bottom that are the same, then we can cross those out. Remember that no matter how complex, anything over itself is 1, and that's kind of the basis of multiplication. And remember that division is just multiplying by the reciprocal. So if you can multiply, then you can divide once you know that first step is to change division to multiplication and then multiply by the reciprocal. Okay, so let's look at this first problem. So the first thing that we have to recognize is that this is over 1. Okay, so we have these two terms. So I need to factor the denominator in the first term. So I have b plus 2. This is going to have a GCF of 8b. So I have 8b times 5b minus 3 times 5b minus 3 over 1. It's important, not necessary to put the over 1, but it might be important so that you don't crisscross what you're supposed to be doing or think you have 5b minus 3 squared. So just be cautious that everything stays where it's supposed to. So now we can cross out. So the 5b minus 3's go away. And that leaves me with b plus 2 in the numerator because this is a 1. And then 8b times 1 is 8b. So remember that this is as simple as you can get it. You cannot cross the b's out. So remember, this is an extension. So just let's make a note here. Okay, this is really just an extension of the distributive rule. So remember that this statement is equivalent to this statement. So now we can mark out these b's, okay, but notice that there's still an 8b over here. Okay, so that 2 is still getting the 8b. So I'm just going to show you quickly how that is an extension. So we know then that this statement and this statement are equivalent statements. By distributive property, I can distribute across and I get this same statement. So this is distributive property. So 8b has to go to b and it has to go to 2b. So you cannot cross out the b's at this particular point in time over here in green. Okay, so you can't cross these b's out because then the 2 is not getting the 8b as well like we did here in purple. Okay, so just be cautious. The rules are the rules are the rules. You'll hear me say this often, and it's because that whatever holds true in the beginning holds true until the end of time. Okay, so we don't change the rules. There's no exceptions. The rule is the rule. Okay. So we have another multiplication problem. So now we have two nice fractions, no ones, and we need to factor. Okay, so we will factor the top of the first problem, and we get x minus 5 and x minus 2. Remember, they have to multiply to be the positive 10, so two negatives multiply to be the positive 10, and add to be the negative 7. So a negative 5 and a negative 2, negative 7. All over x minus 2 times, we can't do anything with the numerator, and then again we need to factor, so we need the factors of 20 that will add to give me a negative 1, so x minus 5 and x plus 4. So once again, a negative 5 and a positive 4 multiply to be a negative 20, but add to be that negative 1x. So then from here, we can start marking out. So everything is multiplying, so any like terms we have in top and bottom, we can mark out. So we have an x minus 5 and an x minus 5, x minus 2 and x minus 2, which leaves me with just an x plus 10 in the numerator and an x plus 4 in the denominator. And just like the previous problem, the x's do not simplify, nor do the 10 and the 4. The only way that the 10 and 4 could simplify is if it was something like 2x plus 10 over 4x plus 4. And then you could divide a 2 out of everything, which is the equivalent of factoring out a GCF on top and bottom and reducing. Okay, so it's the same. So this is just another note, another side note that to make sure that you're not getting your math crossed up. Okay, So this is a GCF. And this, in order to have a GCF, every single term has to have a GCF. And notice that the coefficient of x is 1, so there's not going to be a GCF, okay? So now we have division. So the process is very similar. So some of you were taught the KFC method, and if not, it's just multiplying by the reciprocal. So the first term stays the same, so n minus 7 over, and we can go ahead and factor. So it would be n minus 7 and n plus 5. So again, remember, it has to multiply to be the negative 35, add to be the negative 2. Then we change division to multiplication and take the reciprocal or flip the second term. So that gives me 10n plus 50 over 9n plus 54. Now you can go ahead and factor before you flip if you would like to do that. There's no rule against that. So I'm going to go ahead and go back through and factor n minus 7 over n minus 7, n plus 5, times my GCF in the numerator is a 10, n plus 5, all over my GCF is a 9, n plus 4. So let's go through and cross out. So I have an n minus 7 and an n minus 7, an n plus 5 and an n plus 5, which leaves me with a 10 in the numerator over 9 times n plus 4. So remember, once again, there's no reason to redistribute. It's not wrong to redistribute, but it's not necessary. So you never want to take an unnecessary step because it could cost you points if you do something wrong. And it's kind of just hurtful to lose points for something that you didn't even have to do from the beginning. Okay, so just don't redistribute. It just will save you from making a careless mistake that could cost you points. Okay. So last one, another division. So again, like the first multiplication, you have to remember that this is over 1. So then we take the first fraction. I'm going to go ahead and factor out that GCF of 2. So I have n squared minus 6n minus 27 all over n plus 7. And then I'm going to change division to multiplication, and then I'm going to flip this fraction. So I have 1 over 2, and I can see there's a GCF of 2, so n plus 3. So then I have to go back through and factor this trinomial here in the numerator to get all of my factors out. So I have 2 times n minus 9, n plus 3. So one more time, has to multiply to be that negative 27 and add to be the negative 6. All over n plus 7 times 1 over 2n plus 3. And then we can cross out our like terms. So I have an n plus 3, an n plus 3, a 2, and a 2. So remember, those go to 1. That makes you keep things straight a little bit better. Okay, and then in the numerator, that leaves me with an n minus 9 here, and in the denominator, an n plus 7. And that would be our final answer.